In our previous lectures, we have discussed about hazard. We identify the hazards. Then for more quantitative risk identification, we have done LOPA. So from LOPA, SRS got generated. And based on the SRS, we designed our SIF. Now it is the time to analyze our SIFs. We need to identify how much reliability these SIFs can provide to us. So in our previous video, we have discussed that there are various techniques for reliability analysis of a particular SIF. For example, Markov analysis, parts count technique, etc. Another technique is simplified equation, and this is most simple and easy method and does not specifically needs any tool for analysis. You can use your own Excel where you can give the formulae and you can do your analysis on your own. So in this particular lecture, we are going to discuss, we are basically take the same example for with which we have done HAZOF, with which we have done LOPA, with which we have developed SRS. We have designed the SIF. Now it is time to analyze the SIF, calculate the reliability of the SIF, calculate the PFD average of that particular SIF. So let's begin with it. So the standard is obviously ISA 61511, but from the standard there is another set of directive, you can say. This is not exactly a standard. So this is ISA-84. So this is just provide recommended guidelines. So sometimes reading through the standards become very difficult and it contains so much information there. So what ISA-84 has done, it has taken main points and tried to formulate the thing in much more easy manner and also provided with examples. So in this ISA 84, various simplified equation for various voting logic has been given. So here you can see there are some formulas for the particular voting configuration or particular mode. So if it is like 1 out of 1, it will be half lambda d into t. So here lambda d is the dangerous failure rate. Okay, but we know that failure rate not only consists of lambda d, there is lambda s also, and also there are two parts in the lambda d, that is lambda d u and lambda su. So for simplification here we have taken lambda d, but other failure rates should be included also, right? uh, yeah, so but most of the cases the lambda d becomes the most prominent part of that failure rate, and it has been also seen that if we do the SIL calculation using the lambda d, we get the conservative value of the test interval or the PFD average, right? Again, there are here all the other cases, the equation has been denoted, and also I have done a calculation taking a failure rate of 5e minus 2 and test interval over 1 year, and this is the PFD average that is being generated here. And if you compare with 1 out of 1, you can also see how they really figure. So for 1 out of 1, obviously it is maximum, and for all other case is becoming fraction of that, right? So this is what we need to see in this particular case. So another thing that needs to be highlighted here is while deriving these simplified equations, the common cause factor, the proof test coverage, the test duration and repair time has not been taken into account, right? But they should be taken into account. So that's why I am saying that we will get a PFD average value, but that will be much conservative value if we take the simplified equation. But the value of this equation lies in the fact that it does not need any tools like SIL solver or Excelentia to calculate the PFD average value. You can readily do that by use of Excel. So that is the beauty of this simplified equation, because all of us don't have that these fancy tools, but still you want to do some SIL calculations. How you will do that? So for that, the simplified equation provides you some basis. There may be error in calculation compared to if you do the calculation using the SIL solver, but that will not be that enormous, and you will be obviously getting a conservative result. So that is always good for safety, right? So here another thing I want to mention here, that I am not advocating this use of simplified equation, but only I am expressing my view that if we use the simplified equation, we can have the result in more quickly, and we can um, get the result without using any costly tool. So that's it. So again, uh, this is the example we had. So in this case, what is our SIF? Our SIF is very simple. We have a level switch, and level switch is sending signal to a logic solver, and the logic solver is in turn switching off the valve. This is the XB, right? And this is XB001. So this is the loop. So loop consists of the sensor, a logic solver, and final element, and we have considered these failure rates, right? So well, we cannot consider this failure rate randomly. How to consider failure rate and what failure rate we should consider for different instruments, that will be discussed in a separate lecture. For the time being, you assume that this is an input to your calculation. Again, what is the mode? So the mode you can identify using the PNID. So this answer is 1 out of 1. Logic solver, we have assumed 1 out of 1. If it is like a generic PLC, we have considered, and final element is also 1 out of 1. If we consider the test interval of 4, you see, so we get this PFD of sensor as this, we get PFD of logic solver as this, and PFD of final element as this, and this becomes a total PFD. So if you see the SIL table, this falls under the SIL 1 category. So we can say that we are achieving SIL 1, or rather we should not say we are achieving SIL 1, because to achieve the SIL category there are other requirements that needs to be fulfilled, like we need to see the systematic capability of the system, we need to see the architectural constraint of the system, right? So all these things need to be seen before we can confirm that this loop is really SIL 1 or SIL 2, but at least this is SIL 1 in terms of the PFD average. If we consider that other two things are already being made, then we can consider that this system is SIL 1. So and for SIL 1 again, if we take a test interval of 4 years, then only it is SIL 1. 4 years or less, then it is SIL 1, but the test interval goes beyond 4 years, or it goes at 8 years, then we need to again do the calculation and check whether it still remains SIL 1 or not. So that's it from this particular video. I think there is lots of doubts in your mind and lots of questions that are coming out. So do write in the comment box and I will try to answer them all. Thank you.